Welcome to the deep dive. So, you're a developer. You know your way around blockchain Ethereum. Let's just jump straight in. Today, we're tackling the OP stack.
Yeah, big topic.
Huge. Okay, picture this. Instead of having to build, every single bit of a blockchain from the ground up, imagine you had these really sophisticated, standardized modules, like advanced building blocks.
Integrated circuits, almost. But for blockchains. Yeah, that's a good way to think about it. The OP stack is basically that blueprint.
Right, a blueprint designed for, well, scalability, easy interaction, and not just for rollups, right, or optimistic rollups. It seems broader.
Definitely broader. It shifts the whole game, really.
Yeah.
Away from these sort of isolated, monolithic chains towards a future where you can snap together these purpose-built chains much more easily.
Using a shared foundation that's already been, like, battle-tested.
Exactly. It's kind of like a bet on the Ethereum community's creativity, giving developers better tools to build in a really modular, collaborative way.
And it all leads to this vision of the super chain, which sounds cool, but what is it really? Not just more chains, right?
No, not just multi-chain like we have now with all the clunky bridging, and not one giant, maybe restrictive monochain either.
So something in between or different.
Think highly integrated, a network of these OP stack chains, all designed to work together smoothly.
Okay, that sounds ambitious. And this connects back to the Optimism Collective's whole ethos, doesn't it?
Absolutely. It's deeply rooted in that. Their ideas about humans over capital, impact equals profit. They're trying to solve crypto's coordination problems. It's about building a digital society, not just another ledger technology.
Interesting. So to really get under the hood here, we're looking at some key sources.
Yeah, we're drawing heavily on talks from DevCon 6, specifically Carl Flourish and Kelvin Fichter, and also the original OP Stack intro blog post. Those really lay out the philosophy and the tech.
Got it. So our mission for this deep dive is to go beyond the buzzwords, get into the technical nuts and bolts of the OP stack, really see it from a developer's point of view. What can you actually do with this?
Exactly. What are the possibilities it unlocks? Let's get into it.
Okay, let's start at the beginning. What are the core ideas, the principles that led to the OP stack?
Well, what's really striking when you look back is this constant theme of minimization and modularization.
Yeah.
It wasn't an afterthought. It seems to have been there right from Optimism's early days as a research project.
Focused on scaling Ethereum, right?
Right. And this idea of keeping things simple, breaking them down, it's fundamental.
There's that story about GeoHot, isn't there, that really nails this point.
Oh, yeah, the Transpiler story. It's pretty legendary. Apparently, they had this massive, 6,000-line Transpiler they'd been wrestling with.
For ages, yeah.
And GeoHot comes along and in just a few days replaces the whole thing with a, 300-line modification.
Well,
directly in the Solidity compiler.
yeah,
It's more than efficient. It set a precedent. Simplicity, elegance. That became hugely valued. And you can see that mindset carrying right through into the OP stack design. Code that's easy to understand, easy to audit.
Which is crucial if you want the whole community to build on it, right?
Yeah.
Open source standards need that clarity.
Absolutely critical. So yeah, this commitment to cutting complexity, that's really where the modular design comes from.
Okay, so the OP stack itself, it's the software, the architecture for Optimism's next-gen stuff, but it's not one big program.
No, not at all. It's designed as a series of distinct modules that all work together. Think of it like layers in a stack, each doing its own specific job.
Like a tech stack for a web app, but for a blockchain.
Kind of, yeah. And the really key part for developers is that each of these layers has well-defined APIs, clear interfaces.
Meaning you know exactly how to talk to each piece.
Precisely. And the power comes from being able to, tweak the existing modules or even slot in completely new ones if your specific application needs something different.
That sounds incredibly flexible. I remember the blog post mentioned some wild ideas, like swapping out Ethereum for Celestia for data availability.
Yeah, or even conceptually using Bitcoin as the execution layer. I mean, those are big hypotheticals, but they illustrate the potential flexibility.
It feels like a real shift from theory to practice.
That's exactly what it is. We've seen diagrams of modular blockchains for years, right? Separating consensus, execution, data availability.
Right, the theoretical charts.
The OP stack is the first time, really, that someone's turned those charts into actual working code that developers can use to assemble these things.
And it's built primarily for the Optimism Collective itself, to kind of future-proof their own ecosystem.
That's the driving force, yeah. Make the whole Optimism ecosystem stronger, more adaptable. And a big part of that future-proofing is abstracting the proof layer.
For cross-chain settlement, what does that mean, abstracting it?
It means defining a standard API for how proofs work. So whether you're using fraud proofs today or maybe some super efficient validity proof tomorrow, as long as it fits the API, you can swap it in.
Without breaking everything for the users.
Exactly. Users shouldn't even notice. It gives you that forward compatibility, lets you adopt new proof tech as it gets better.
Okay, so we have these swappable modules. How does that lead to the super chain idea, the interconnected chains?
Well, releasing the OP stack is seen as the first step, the catalyst. The idea is to spark this explosion almost of compatible L2s, maybe even L3s, all built on this shared OP stack foundation. Those are the op chains.
And because they all use the same standard hardened modular code, they can just naturally work together better.
That's the core idea. They're inherently designed for interoperability. They've even defined a standard message passing format between op chains.
Ah, so no more building custom bridges for every single connection.
Hopefully much less of that, yeah. Easier communication, more seamless interaction between these chains.
So it's scaling, but also scaling the values of optimism, that human-centric approach, across this whole network.
That's certainly part of the vision. Now, one key thing to consider with all these potential op chains is sequencing. Who orders the transactions?
Right. Can each chain just run its own sequencer?
It can, technically, but running a sequencer, especially a decentralized one, is complex. You need liveness guarantees, censorship resistance. It's a big job.
Kind of like how optimism initially relied on Ethereum's consensus.
Exactly like that. Building a robust decentralized sequencer network isn't trivial. So it's likely many new op chains might choose to leverage a shared sequencer infrastructure, at least initially.
Outsource the complexity, focus on their unique thing.
Makes sense, right? Focus resources where they add the most value for that specific chain's purpose.
This actually leads nicely into Kelvin Fichters's DevCon talk. He really dug into the theory behind modular rollups and how the OP stack makes it real, didn't he?
He did. His talk is fantastic for bridging that gap between the abstract concepts and the actual concrete APIs and functions you'd use in the OP stack. It's the how-to guide.
He had that funny term, beefcake rollups.
Yeah. His term for the early monolithic designs, where everything, data availability, execution, settlement, was all bundled tightly together.
Before we realized you could pull things apart.
Exactly. Like Arbitrum Nova separating out data availability with their committee, that was a huge step towards this modular thinking.
So the OP stack takes these separated layers, consensus, execution, settlement, and gives them formal software interfaces.
Right. It provides the actual building blocks. Kelvin breaks consensus down further into data availability and derivation. Then you have execution and finally settlement.
Okay, let's walk through those. Data availability first. In OP stack terms, what is that technically?
Fundamentally, it's just an ordered list of blobs. Think of blobs as just arrays of bytes, raw data chunks in sequence.
A simple ordered stream of data.
At its core, yes. But practically, you need guarantees. It should be mostly immutable, hard to change past data, append only, easy to add new data, and crucially, the data has to actually be available. Someone needs to be able to fetch it.
Makes sense. So in Ethereum, what acts as these blobs?
Well, the simplest example is just the Ethereum blocks themselves. Each block is a blob of transaction data, and then you have EIP 4844, the proto-dank sharding blobs. Those are designed for this. Or you could use external DA layers like Celestia.
Kelvin even joked about a stack of Post-it notes, right?
Yeah, just to highlight the pure abstraction. Any ordered available data source could theoretically work.
Okay, so we've got this stream of raw data blobs. How does an L2 make sense of it? That's derivation.
Exactly. Derivation is the layer that takes the raw blob data from the DA layer, looks at the current L2 state, and figures out what inputs to feed the L2 chain. Usually that means extracting or generating transactions.
And the OP stack uses Ethereum's Engine API for this. Why reuse that?
It's pragmatic. Optimism is EVM equivalent. Ethereum already figured out how to separate consensus, like L1 block production, from execution, the EVM, using the Engine API. So why reinvent the wheel? They just reuse that standard interface to drive L2 execution.
Smart. So functionally, derivation takes the old L2 state and the new DA data.
And now puts either a payload, basically the next block's worth of L2 transactions or instructions, or nothing if there's no relevant data to process in that blob.
And in Bedrock, Optimism's current setup, where does it actually get this L1 data from?
Several places. Primarily, the sequencer posts batches of compressed L2 blocks to a specific L1 address. Derivation pulls data from there. It's complex to unpack efficiently, apparently quite optimized.
But it also looks at L1 deposits.
Yes, when you deposit ETH or tokens via the L1 portal contract, that emits an event. The derivation layer sees that event and creates a corresponding L2 deposit transaction. That's how stuff gets from L1 to L2.
And L1 block info too.
Right. Each L1 block triggers a special L2 transaction containing info like the L1 block hash and base fee, keeping the L2 aware of the L1 context.
The flexibility seems huge here. Kelvin's example of an L2 that only processes L1 Uniswap events to build an indexer. That's wild.
It really shows the power.
Yeah.
You can derive L2 activity from basically any information on L1 or the DA layer. You're not limited to just user transactions submitted directly to L2. Opens up a massive design space.
Okay, so derivation creates payloads, then comes the execution layer. This is the state transition part.
Yep, this is the heart of the blockchain logic. It takes the current state, takes a payload from derivation, applies the rules, and produces the next state. Simple concept. Execution, previous state, payload.
It's that core loop. DA layer feeds derivation produces payload, maybe execution processes payload, update state, wait for next DA blob.
Precisely. That's the cycle.
And in Bedrock, execution is mostly the EVM, but slightly modified.
Right, it's based on Gethko Ethereum. The main change is adding a specific transaction type for those L1 to L2 deposits we talked about. That message passing is key.
And the code difference is tiny, like under 1,000 lines.
Surprisingly small, yeah. Something like 750 lines if you ignore config files. It's a deliberate design choice. Keep it minimal, makes it easier to maintain EVM equivalence.
And crucially, easier to support multiple clients, like opgeth and opref.
Exactly. Client diversity is huge for resilience. If opgeth had a critical bug, but opref nodes were running correctly, the network could potentially recover. Relying on one client is risky.
And just because Bedrock uses the EVM now doesn't lock the OP stack into it forever. Bitcoin logic, Game Boy emulator, Python.
Theoretically, yes. As long as your execution engine, whatever it is, can process the payloads from derivation and talk via the engine API, you could plug it in. That's modularity.
Mind blown slightly. Okay, final piece, settlement. This sounds more abstract. Making claims about your chain to another chain.
Yeah, settlement is about establishing a verifiable view of your chain state on another chain. Usually that means settling to a more secure chain, like Ethereum L1. And you can even settle to multiple chains at once.
And the claim is usually the state root, a hash representing everything.
That's the most common one. To verify these claims, you need a validity function. Think. Validity, old state, new state, data, derivation logic, execution logic, true, false. Does this state transition check out according to the rules?
But running that whole check on L1 would be crazy expensive.
Prohibitively so, which is why in practice, the derivation and execution logic parts are usually represented by proofs, fault proofs, or validity, ZK proofs. They let you prove the transition was correct without rerunning it all on the settlement layer.
And the validity function needs access to the original data, right? The getBlobby index thing.
Crucial point. That function lets the settlement layer fetch a specific data blob from the DA layer. It implies two things. One, the data actually needs to be available. And two, there must be a way to prove the blob you fetched is the correct one, usually via cryptographic commitments.
Like Kelvin's Celestia example. Needs Celestia commitments on Ethereum, proofs against those commitments, trusting the light client bringing them over.
Right. Now, when Bedrock settles directly on Ethereum L1, it's a bit simpler. The validation process can actually rederive the L2 chain by reading the transaction data directly from L1 blocks, since L1 is the DA layer in this case, and compare the result to the proposed state root in the fault proof. Data availability and correctness are kind of inherent.
Okay, quick recap. DA layer, blob stream, derivation, blobs to payload, execution, payload to new state, settlement, proving state transitions to another chain using proofs and DA access via getBlobby index. Each is a pluggable API.
You got it. And Kelvin's point is key. The tech to build all sorts of crazy stuff, Bitcoin Plasma, complex bridges, it exists now in the Bedrock code base. It's ready for developers to play with.
This feels massive. Let's zoom out again. How does this fit into the wider Ethereum scaling picture? That Bankless clip positioned the OP stack as a total game changer.
Yeah, they really emphasized its potential impact. They contrasted the different L2 approaches, Optimism, Arbitrum, ZK Sync, Darknet, all with their unique designs.
And said the OP stack is different, like a meta layer.
Exactly, a scaffolding standard. A way to modularize all the different parts of an L2 into open source modules, like a build a layer 2 workshop.
Where maybe Arbitrum's fraud proofs could become one module, ZK Sync's prover another, conceptually.
That's the idea. Abstracting the best bits from everywhere. The ERC20 analogy they used is powerful. Just like ERC20 made launching tokens easy, OP-Stack aims to make launching specialized L2s way easier.
And everyone benefits from shared modules. The secret sauce isn't so secret anymore if it becomes a standard OP stack module.
Which leads to that Peloton idea. How can one team possibly out-innovate the entire ecosystem, contributing improvements back into the shared OP stack? The collective pace becomes immense.
Leading ultimately to the superchain. A single network feel, solving the bridging nightmare, and network switching.
That's the user experience goal. Address the current mess. Fragmented L2s, insecure bridges, confusing UX. Users want simple, cheap, seamless, ideally synchronous.
And standardization via the OP stack is the path there. Consensus layer modules, rollups are one type, execution layer modules, EVM or others like that Minecraft, Upcraft thing.
And the settlement layer. It provides the framework.
I liked the selfish gene analogy too. Modularity creating this competitive ecosystem where chains optimize for UX under a common standard, pushing crypto complexity into the background.
It's a compelling vision. Competition driving user-friendliness on top of shared, secure infrastructure.
Okay, let's get even more technical. The OP Labs Deep Dive Workshop from ETH Global.
This gets into the specific software, right? OpNode, OpGeth.
Exactly. It shows the practical architecture. OpNode handles the consensus layer stuff, tracking L1, deriving L2 blocks, talking to other nodes. OpGeth, or potentially OpReth, is the execution layer running the EVM state transitions. Clear separation. And the sequencer. Centralized, for now, on OpAINit.
Yes, currently. It builds that unsafe chain, rapidly 2-second blocks, by ordering incoming transactions.
Unsafe because it hasn't hit L1 yet.
Right. Those unsafe blocks get gossiped around the L2 network immediately by the op nodes.
Then the op batcher steps in.
Yep. It grabs the latest unsafe blocks from the sequencer, compresses them, and submits them as batches onto L1, using blobs now, which is cheaper. That's what anchors the L2 data to L1 security.
And other op nodes, the validators, watch L1, grab those batches, and replay the transactions to verify the sequencer's work.
Correct. They derive the L2 chain from the L1 data. L1 data is the ultimate truth, so if the sequencer submitted something faulty, validators would ignore it and follow the L1 data, potentially causing a reorg on L2.
Which gives us the safe chain derived from L1 batches and eventually the finalized chain once the L1 data itself is finalized.
Exactly. Layers of confirmation.
The workshop also detailed the deposit flow again. L1 portal contract emits event, L2 derivation picks it up. Forced inclusion is key for censorship resistance.
Right, the sequencer must include L1 deposit transactions, according to the L2 consensus rules. It's not optional. This also updates things like the L1 base fee info on L2.
Withdrawals are more complex, though. L2 transaction, message passer, proposer submits state roots to L1, user provides proof against the root.
And the fault-proof system allows challenges. It's a multi-step security process to get assets back to L1 safely.
The technical insight about reading L1 state for deposits being part of L2 consensus was interesting. It's baked right into the rules.
Yeah, it's fundamental to the bridge security. And they mentioned bridging ETH, ERC20s, NFTs, usually using paired L1, L2 bridge contracts managed via the portal.
And they stressed OpGeth being close to upstream Geth for easier maintenance and EVM equivalents, plus the importance of client diversity, OpReth. The diff browser is neat for devs.
For sure. And the local DevNet setup, OpNode, OpGeth, OpBatcher, locally via definitely L1 template, sounds super useful for just trying things out. Standard RPC ports, easy access.
Then they got into the fun hack ideas. Alternative DA layers using a simple REST API, S3 or file storage examples.
Shows the modularity. Define the DA interface, implement it however you want. Shared sequencing is harder, they noted.
Hacking the execution layer, too. Adding precompiles like EIP 712 support.
Yeah, modify OpGeth, or your client, to add new capabilities. Or adding new L2 asset types like ERC 1155s, which usually needs new bridge contracts.
They even touched on L3s having a block time limit based on the L2, and custom gas tokens filtering L2TX based on L1 events. The possibilities seem endless.
It really drives home how flexible the OP stack is designed to be, a platform for building all sorts of custom chain logic.
Okay, final piece. The interop design overview. How do all these OP stack chains actually talk to each other? This is the superchain plumbing.
Right, the vision here is modular applications. Shard, gas-heavy parts across multiple chains, but keep the user experience smooth. Like, distribute components of a dApp horizontally.
Assuming users will demand low latency, seamless interaction like the web.
Exactly. And the key insight is that interop between chains with the same security model, like two OP stack chains, should be fundamentally simpler and cheaper than connecting chains with totally different security assumptions. Homogeneous interop is easier.
Makes sense. And it's asynchronous by default, but can be synchronous if block builders coordinate.
Yeah, no requirement for global synchrony, but coordination can enable it. They introduce an L1 system config contract where chains declare dependencies, which other chains they'll accept messages from.
Declaring is permissionless, but you have to actually run nodes for the chains you depend on.
Naturally, yeah, you need to process their state.
And the messages. An initiating message, an event on the source chain, and an executing message, a transaction on the destination.
Spot on. The executing message is basically a call to a pre-deployed contract executed message on the destination chain. It contains the source event data and a pointer back to that specific event, chain ID, block number, log index.
And the crucial security bit. The destination chain's fork choice rule enforces that the pointer in the execute message call is valid. Sequencers must check it.
Yes, that link integrity is guaranteed by consensus. If a sequencer includes a message with a bad pointer, honest nodes will reorg it out. That's the trust mechanism.
They're also removing the only EOA rule for sending messages, embracing smart contract wallets now, especially with EIP 30074 coming.
Right, adapting to the reality of smart contract wallets and figuring out how to handle potential DOS issues with scalable backend validation instead of just banning contracts from sending messages.
The use cases were cool. Sharded NFT marketplace minting on one chain, trading on another, storage maybe elsewhere.
Exactly. Or a DAX order book spread across multiple OP stack EVMs for horizontal scaling. Break down monolithic apps.
It's this idea of verifiable compute as a resource, less about chains, more about application-specific sets of compute resources settling to a main layer.
A fundamental shift in thinking. They have layers for this interop too. The low-level cross L2 inbox, guaranteed event reading via fork choice, and a higher-level cross-domain messenger.
The messenger adds replay protection, domain binding for things like superchain ERC20s, and it's permissionless.
Yep, higher-level convenience, still permissionless. You can even send payments with messages using payable functions.
And potential for atomic composability if the same builder makes blocks on multiple chains at once.
That's the really exciting frontier, simultaneous actions across chains. They're targeting Q4 2025 for production release, encouraging folks to check specs.optimism.io and join the GitHub discussions.
It's happening fast.
Definitely a space to watch closely. It's the key to making the superchain actually work as envisioned.
Okay, let's try and wrap this up. It's clear the OP stack is this incredibly modular, really powerful framework. It's for building blockchains that are scalable and, maybe most importantly, designed to work together.
It's the engine driving that superchain vision. Lots of interconnected chains built on common ground, working seamlessly.
And for developers listening, the potential seems huge. Build custom solutions, swap out components, play with data availability, execution, interop. It's a massive toolkit.
Absolutely. Experimentation is key. Alternate DA layers, different VMs, new cross-chain patterns. The design space is wide open.
And it's all still evolving, right? This isn't finished. There's a real chance for developers to get involved, contribute, help shape what comes next.
For sure. Check the specs, join the discussions, build stuff. It's a very active ecosystem.
So, final thought to leave people with. If this vision plays out, if we move towards application-specific chains, all seamlessly connected by the OP stack, what does that actually enable? What new kinds of dApps, what new user experiences become possible when the underlying chain just fades into the background?
That's the big question, isn't it? When the infrastructure becomes truly flexible and invisible, what can we build on top? Definitely something to think about. Explore the resources, dive deeper.